All right, hear me? Great. So now that we've passed our slide problems. Hi everyone, my name is Eli Goldberg. I'm the Director of Platform Engineering at Salt Security. Bit about me, these are my homegrown animals, Alice the cat and Mango the dog, or as we call him by his office name, Mongo. Salt Security. So Salt is a API security company. We basically protect APIs by looking at our customers' traffic. We build a model of their APIs and we identify potential attackers doing so. We handle billions of daily requests and we love Linkerd, and I'm happy to share why. So around 2 years ago, we were running about 20 microservices on Kubernetes, mostly Scala. And they communicate with each other mostly via HTTP and some other proprietary protocols. And as the teams were getting bigger, some of the challenges we've had was to prevent APIs from breaking internally. So we've seen programmers introduce new programming languages, and it's becoming harder and harder to solve those problems from the code itself. And we started thinking outside the box, and we're looking for tools that will make it easier. So just to illustrate the level of complexity, this is what we've had around 2 years ago. And over time, we started seeing a more complicated pictures, more programming languages, more inputs. And gRPC was a great solution for us because it allowed us to create a single centralized schema to actually see our entire APIs in a single repository. It was much easier because you could just call a function and generated source code library instead of having to recreate your serialization and deserialization JSON requests. And protobuf is much more efficient, much smaller payloads. The problem is that when you introduce gRPC into your stack, you lose one capability, which is load balancing. So unlike HTTP1, gRPC is based on HTTP2, which basically reuses the same connections over different requests. And then you have to figure out another way to keep your load balancing capabilities in Kubernetes. But there are multiple ways to solve this. There is, of course, client-side load balancing, but since we wanted to solve it in a language-agnostic way, we preferred to solve it at the network level. And since our use case was focused, we wanted to solve the gRPC load balancing issue. Our primary candidate was Linkerd. Going to staging, it took us a few minutes to deploy to our staging cluster. Running a few load testing scenarios showed a 250% performance increase just by introducing gRPC and Linkerd. And we thought that we'd let it run for a couple of days before we go full production, just to gain some confidence. Production end-to-end work was about 5 days. It was mainly about switching Linkerd to work as a highly available solution. And we wanted to deploy it in a more GitOps approach. So we used the Helm charts wrapped around with Terraform. We've set out to solve a simple and single problem that we've had, which is the gRPC load balancing. But we've actually gained so much more. So our connections were now MTLS encrypted end-to-end between our pods. We've started seeing a whole network. All the communication between the services was now in front of our eyes. And also it opened the door for us for a few more interesting features that Linkerd has to offer that we've already implemented, such as gRPC retries and per team monitoring alerts to actually be able to tell teams as a platform team, hey, you have a problem here, go check it out, without even knowing about which service or which call they're doing. So if that was the complexity we were talking about, now we're starting to see all the connectivity between the services, which ones were failing, and a fairly easy way of pointing the finger into where a problem persists in the cluster. Aside from production, we started seeing teams utilize Linkerd for development environments as well, to actually verify the correct behavior for their services and their deployments before they reach production, which is pretty cool to see. We're super excited about the upcoming features. So there's circuit breaking that was just released in Linkerd 2.13. And things like multi-cluster, multi-cloud, Linkerd at the edge, and counter redeployments as well. So The fact is that we're not Linkerd experts, but we're able to do all that. Means that Linkerd is a super simple but powerful tool, and it has an incredibly welcoming and supportive community, and we're grateful for that. If you have any questions, please, this is my Twitter handle, or find me via email. Thank you.
Thank you. Once again, I'm going to ask Eli to be available.